Hey class, someone also asked for some helpful pointers on problem number 59. So here we go. So problem 59, we're told that you have a person that is standing on top of a high board, or high diving board, or tower, and is going to be diving off into the water. So here's our diving board, tower, and there's going to be a person up here. Person looks a little bit nervous. Actually, you can't quite see it here. We'll make a better picture. A little bit nervous to be jumping off this big diving board down into the water. Here's the water, and we're told that the person penetrates into the water a certain depth. Okay, so if we call this depth that they penetrate into the water, maybe we'll call that a distance of y1. Then we also know that the diving board starts some distance above the water, y2. So the total height that the person dives down can be labeled as this distance here, which I'll call the total h, which is just equal to y2 plus y1. Alright, so if we want to think about what's going on in terms of energy, the person is starting with some initial potential energy initial, that's going to be equal to mg times h. When they start, they're not going to have any kinetic energy because their velocity before they leave, v initial, is just going to be equal to 0. And the velocity when they end, since the water brings them to a stop, is also 0, which is nice. So there's actually no kinetic energy at the beginning or the end. So our kinetic energy initial equals 0, as does our kinetic energy final. So what else is going on here? Well, while the person is in the water, they are going to be experiencing an upward resistive force from the water. So there's a force upward acting on them just in the time that they're in the water, and that force is going to be doing non-conservative work. So there's going to be work done by non-conservative force, which is equal to negative F multiplied by y1. Why is it negative? Because the force is in the opposite direction of the displacement. So we know it's a negative work. So you're going to be setting up your conservation of energy, kinetic energy initial, which we've already decided is 0, plus potential energy initial, plus work done by non-conservative forces is equal to kinetic energy final plus potential energy final. The crazy thing is that our kinetic energy final is 0 and the potential energy final is 0 if we define the bottom down here as your 0 location. So all you're left with is that your potential energy initial plus the work done by non-conservative forces equals 0. And so you hopefully should be able to solve this using the information that we have up here. Okay, so that's all I'm going to give you for now as a starter, but I hope that helps, and let me know if you have any additional questions.